Hello students, welcome back to the maths class. In our previous class, we have learned about the product of two vectors. That is the first one in that is the scalar product or the dot product of two vectors. Now, in today's class, let us learn about the vector product or the cross product of two vectors. So, in this, now let's consider two vectors. So I'm considering vector A and vector B. So these two vectors are non-zero vectors. These are what kind of vectors? They are non-zero vectors. When I consider the two vectors, which is vector A and vector B, and these two are non-zero vectors, then the cross product between the two vectors, which we denote it as vector A cross vector B. This is how we denote the cross product between two vectors. So vector A cross vector B is defined as magnitude of vector A into magnitude of vector B into sine theta into n cap. Okay, so this is the definition for the vector product or the cross product. Now here, as we say vector product, the resultant of the product of these two vectors is a vector again. And we already know what is a vector. A vector is that quantity which has got both magnitude and scalar. So here, this part defines the magnitude of the vector, which is a resultant vector from these two vectors, and this gives us the direction. Okay, if you remember the the dot product between the two vectors, which we have discussed in the previous classes. Okay, there we told that the dot product between the two vectors is just a scalar. So we are getting only a scalar quantity, only the magnitude. We were not bothered about the direction because it is just a magnitude. Now here, when I say the cross product between the two vectors is a vector, means it is both magnitude and direction. So here what I am considering is, let us consider the two vectors. Say this is our vector A and one more vector. So this is my vector B. Both are co-initial vectors, that is, these two vectors are starting at the same initial point. The angle made by these two vectors is theta. Okay. So according to the definition, when I take a cross product between these two vectors, I get a magnitude of vector A, magnitude of vector B into sine theta. When I make a cross product between these two vectors, I get a vector as a resultant. So that vector we call it as A cross B. Vector A cross vector B. This is the resultant vector, one vector. Okay. So this vector is actually in the direction of the unit normal vector. Unit normal vector. So n cap I am calling it as unit normal vector. So what is normal? Normal is nothing but a perpendicular. Okay, unit vector, a vector whose magnitude is unity. So that is the resultant vector of these two vectors is perpendicular to this vector. Okay, so it is perpendicular to this vector. So this is our resultant vector, which is A cross B, which is perpendicular, means it is along the direction of which vector? N cap, that is unit normal vector. So this is n cap, you can say, whose magnitude is 1. The direction in which the n cap is moving our resultant, that is vector A cross vector B, resultant vector is moving along the direction of unit normal vector. Understood? Means we are getting actually a vector as a resultant vector. So for a vector, definitely you should be having some direction. That direction is what? That direction is same as the direction of the unit normal vector. Okay, so this direction is determined by rule called as right hand thumb rule. What does this rule say is, if I take a vector, okay, once if I take my right hand and I place on vector A, then I take a curve, means I am making an angle theta with vector B, then my thumb shows this direction. That direction is actually the direction of the unit normal vector, and that is the direction in which a resultant vector is traveling. That is the direction in which the our resultant vector has its direction. Okay, so according to the right hand thumb rule, what? I place my right hand on my first vector, that is vector A. Now I take a curve, that is I am making an angle theta with a vector B. My thumb shows a direction. In this direction, I get my resultant vector, and this is perpendicular to the plane in which my vector A and vector B is lying. Okay, so this is about the definition of the vector product or cross product of two vectors. I'm going to write the definition. The vector product of two non-zero vectors, vector A and vector B, is denoted as vector A cross vector B and is defined as what? Vector A cross vector B is equal to magnitude of vector A into magnitude of vector B sin theta into n cap. Okay, so this is about the definition. You should remember this definition. Now, with this only, I told that here, in order to find the direction, we use right hand thumb rule. So when we are using a right hand thumb rule, in case if I take vector B as my first vector, okay. So again here I am using the right hand thumb rule in order to find the direction in which our resultant vector is traveling. So here what I do, I place my right hand on vector B. Now I take a curve, making an angle of theta to come to vector A. So my thumb is in which direction? It is in the direction opposite to our previous vector n cap. So this will be the direction. So this will be our n means unit vector, but is in opposite direction. So minus of n cap. So when I take B as my first vector, okay, then I am finding a cross product between B and A, that is B cross A. Then, okay, then we have B cross A will be equal to, the magnitude remains same, the magnitude is unchanged. So even you can write vector magnitude of vector A dot magnitude of vector A into magnitude of vector B sin theta, or magnitude of vector B into magnitude of vector A sin theta. This can be interchanged because the magnitude, if you interchange also, doesn't matter. But the direction is in which direction? In the direction of minus n cap. So this will be equal to minus of magnitude of vector B into magnitude of vector A into sin theta into n cap. So this is minus of, this is same as our A cross B. So minus of A cross B. Vector B cross A will be always equal to minus of vector A cross B. You should keep it in mind. This is very important. So what does this conclude? This conclude that we cannot write vector A cross B cannot be equal to vector B cross A. That is, we can say that the cross product is not commutative. Very important result. So you should remember, whereas in dot product, we have seen that A dot B is vector A dot B is same as vector B dot A. That is, the dot product is commutative. But in cross product, it is not same. Why? Because in cross product, we are getting a resultant as a vector. So here the direction changes when we say A cross B and B cross A. So here it is not commutative. I hope you have understood. Now let us move to the observations based on the definition of the cross product of two vectors. Now let us see what are the observations based on the definition of the cross product. So first observation is that, so as the name says, when I take cross product between the two vectors, the resultant is what kind? It is a vector again. So A cross B is a vector. This is my first observation. Second observation, I see that vector A cross vector B is equal to 0. This is possible when you have again two conditions here. This can be possible in two conditions. Where the first condition is that when either vector A is a 0 vector or vector B is a 0 vector. Okay, if either one of the vector is a 0 vector, then again the cross product between the two vectors is 0. Okay, so when either A is 0 or B is 0, under this condition, the cross product between the two vectors is 0. In this case, you should remember theta is not defined. Okay, why theta is not defined? See, if I take vector A and vector B, if one of the vector is a 0 vector, I don't have this vector itself. If A is 0, I don't have vector. So theta will be, there is no angle between the two vectors. So theta will be not defined under that case. What is our next case where our cross product between the two vectors is 0? Let us see. So I say that if in case theta is 0, okay, if theta is 0, then I say that vector A cross B is equal to 0. That is, see here, we know that vector A cross vector B is equal to magnitude of vector A into magnitude of vector B sine theta into n cap. In the case where the angle between the two vectors is 0, then magnitude of vector A, magnitude of vector B sine 0 into n cap. What is the value of sine 0? It is 0. Therefore, 0 into anything, it is 0 again. So, in the case when theta is 0, then we say that vector A and vector A cross vector B is equal to 0. But you should make sure that in this case, okay, A and B are both are non-zero vectors. That you should keep it in mind. Here, vector A and vector B are non-zero. Okay, they are non-zero vectors, but still we have a condition where the cross product between the two vectors is a 0. So, under this condition, where theta is 0, then the cross product between the two vectors is 0. What does this imply? That is, if A cross B, vector A cross vector B is 0, this implies that vector A is parallel to vector B. That is, if I take two vectors, that is vector A and vector B, both are non-zero vectors. So this is vector A. So you have another vector, say this entire vector, the pink line which I have written, pink arrow line which I have written, that is vector B. What is the angle between these two vectors? It is 0, but they are a non-zero vectors. The angle between them is 0. So I can say that these two vectors are what kind of a vector? They are parallel vectors. Okay, we have seen the condition. If one vector is lambda times the other vector, we can say that they are parallel vectors. So under this condition, again when theta is equal to 0, we can say that vector A cross vector B is equal to 0. This implies that vector A is parallel to vector B. You should remember this. It is very important. In cross product, in dot product, if vector A dot vector B is equal to 0, what does that imply? That implies that vector A is perpendicular to vector B. Okay, in dot it is perpendicular, in cross it is parallel. So this is one of the important observations. So this can be even said as, if vector A is parallel to vector B, then this imply that vector A cross vector B is equal to 0. Okay, remember this. I hope you don't have any confusion between the dot and cross. I repeat this observation again. So here in the observation 2, we have told that the cross product between the two vectors is 0. This can happen in two cases. The first case is where if either one of the vector is a 0 vector, then if I find the product between a 0 vector and another vector, then definitely it will be a 0 vector. The second case is where both the vectors, vector A and vector B, are actually a non-zero vectors, but still the cross product between them will be equal to 0, where the two vectors are parallel. Under the condition when the two vectors are parallel, definitely the cross product between the two vectors will be equal to 0. Okay, next, moving on to the next observation. So here, the next observation, we have just now seen when theta is equal to 0, if theta is equal to 0, then we get vector A cross vector B as equal to what? 0. Because these two are parallel vectors. In particular, A cross A will be equal to what? It is again equal to 0 here. Okay. In particular, even A cross A will be equal to 0. Next, fourth observation. In the case where theta is equal to 180 degree, okay, means the angle between the two vectors is 180 degree, then what happens? So under that condition, then vector A cross vector B is again equal to 0. Means this is a vector A. You have another vector B, the angle between them is 180 degrees. Okay, sine 180, value of sine 180 is again 0. So when you apply this in the definition of the cross product, you will get magnitude of vector A, magnitude of vector B, sine theta. Here what is the angle theta? It is 180 degrees into n cap. And we know that sine 180 degrees is equal to 0. So this entire value will be equal to 0. So from this, we know that when angle theta is equal to pi, then A cross B will be again equal to 0. In particular, okay, if you have A cross minus A, then this will be equal to 0 again. So next observation, this is when we have angle theta is equal to 0. This is when angle theta is equal to pi. Now let us see what happens if I take an angle theta which is equal to pi by 2. So if theta is equal to pi by 2, then what happens? Vector A cross vector B will be equal to magnitude of vector A into magnitude of vector B. Why? Why? Because sine 90 degree is equal to 1. And n cap is what? It is a unit normal vector. Unit vector means again its magnitude is 1. Therefore, here vector A cross vector B will be just equal to magnitude of A into magnitude of B. Understood? Next, we have the next observation for mutually perpendicular unit vectors. Okay, for mutually perpendicular unit vectors. I cross I. Can you tell what is the value of vector I cross vector I? Just look at the observation 3. So if you have A cross A, this will be 0. If I take I cross I, these two vectors are parallel now. The angle between them is 0. Therefore, I cross I will be equal to what? 0. Similarly, J cross J, J cap cross J cap, and even K cross cap, K cross is also equal to 0. Okay? Don't get confused between the dot product and cross product. You should remember the definition in order to remember. The angle here is sine theta. When they are, the angle between them is, means the angle is sine, we are considering sine theta here. When we consider sine theta in the cross product, okay, when they are parallel, the angle between them will be equal to 0. Sine 0 is equal to what? 0. Therefore, I cross I, J cross J and K cross K is equal to 0. Now, what is the value of I cross J? I cap cross J cap. Now, let us see what happens here. This is your x-axis, this is y-axis, and you have z-axis. Okay, this is the origin. I cap is the unit vector along x-axis, J is the unit vector along the y-axis, and K is the unit vector along the z-axis. We are finding what here? We are finding the cross product between the two vectors. So here, okay, if I consider these three are mutually perpendicular vectors. So, if this is your vector A and this is your vector B, okay? So, this is your vector A and this is your vector B. If I apply a right hand rule here, okay? If I apply right hand rule here and I take this right hand rule from I to J, if I am applying the right hand rule, then my resultant vector will be along the unit vector K cap. Okay, so this will be equal to K cap. Next, if I take J cross K cap, then this will be equal to this. You can easily see this J K. So when I apply a right hand thumb rule, this will be in the direction of this one. See, this is perpendicular to this one. So when I see this will be like this will be perpendicular. So you should imagine that when it comes to 3D figure, so J cross K will be equal to I cap. Then when you take K cross I, so here when you take K cross I, so this is my right hand, K cross I, it is moving along which direction? J. So you have K cross J, K cap cross J cap, which is equal to K cross I cap, which is equal to J cap. Okay, understood? So this is important. Now, if I take J cap cross I cap, what happens? J cap cross I cap. This we can easily see because I've already discussed in the definition only. We have already shown that vector A cross B is equal to minus of vector B cross A. So, vector A cross B is equal to minus of vector B cross A. So, this will be equal to what? Minus of K cap. Okay. Then similarly, K cap cross j cap will be equal to minus I cap, and I cap cross j cap will be equal to minus of j cap. What is the method of remembering this? Is I, J, K, write it in a cyclic order. Okay, so I cap cross j cap will be equal to k cap. J cap cross k cap will be equal to I cap. K cap cross I cap will be equal to j cap. But if we take j cap cross I cap, then it will be equal to minus of k cap. Through this, you can remember. Let's see the next observation. So here we are going to find the angle between the two vectors. So angle between two vectors, vector A and vector B, is given by, okay. So for this, first I should consider the definition of the cross product between the two vectors. Here, I apply the magnitude on both the sides of the equation. Why I am applying this? When I say angle between the two vectors, it is just a magnitude. We doesn't consider any direction there. There will be no direction. So here, vector A cross vector B. So again applying magnitude on the magnitude is again a magnitude. So magnitude of A, magnitude of B into sine theta. Magnitude of n cap is what? It is 1. So this will be equal to magnitude of A, magnitude of B sine theta. From this, can you tell me what is the angle between the two vectors, vector A and vector B? So angle between the two vectors, vector A and vector B, given by sine theta is equal to magnitude of vector A cross B by magnitude of vector A into magnitude of vector B. This is in terms of vector product. Okay, so the angle between the two vectors, vector A and vector B, is given by sine theta, which is equal to magnitude of vector A cross vector B divided by magnitude of A into magnitude of B. Here, the one thing you should remember is, so whenever they ask in your exam, what is the angle between the two vectors, you are going to use cos theta is equal to vector A dot vector B by magnitude of vector A into magnitude of vector B. This alone. Only in the case where it is specified in terms of vector product, then only you are going to use sine theta formula. Or else always, if they have not specified anything and if they ask only what is the angle between the two vectors, we always use this formula and not this formula. Okay, I hope I am clear. So whenever they are asking angle between the two vectors, we are going to use this formula. Only in the case where they have specified in terms of vector product, we are going to use the formula of sine theta. Next observation, 8.1. Now let us find what is the area of the parallelogram with the help of the vector product. So let A and B be two adjacent sides of parallelogram. Okay, so we have a parallelogram. This is vector A, this is vector B. The angle made by them is theta. We know that area of parallelogram is equal to base into height. Yes. So what is the base of the parallelogram here? It is vector A. But when I say base, we are taking only the length, that is only the magnitude. So base will be what? Magnitude of vector A. Now let us find what is its height. In order to find the height, I draw a perpendicular from here. So if you see, you have got a right angled triangle. So when you have a right angled triangle, so let us define what is sine theta according to that. So this is your height of the parallelogram. Let us define sine theta. Sine theta is given by opposite by hypotenuse. So what is the opposite here? Height h. By hypotenuse you have a vector v, but we need only the length. So we are going to take what? We are going to take only its magnitude. So magnitude of vector v. So magnitude of vector v into sine theta gives us what? It gives us the height of the parallelogram. So I can write the height of the parallelogram as magnitude of v into sine theta. What is magnitude of vector e into magnitude of vector v into sine theta? See here, magnitude of vector A, magnitude of V into sine theta is given by what? It is given by magnitude of vector A cross B. Okay, remember? So, when A and B are two adjacent sides of the parallelogram, then the area of the parallelogram is given by magnitude of vector A cross vector B. With this, now let us understand what is how to find the area of the triangle. Here only you can just say how to find the area of the triangle. So with the help of the parallelogram, with the help of the area of the parallelogram, let us find what is the area of the triangle. So if I draw a diagonal to this parallelogram, okay, so this is your diagonal to the parallelogram. So this parallelogram got divided into two. It got divided into two geometrical figure called as triangle. So if the entire area of the parallelogram is magnitude of A cross B, what will be the area of the triangle now? It is nothing but half of this one. So I can easily write area of triangle is equal to half of area of the parallelogram. So what is that area of the parallelogram is? It is magnitude of vector A cross vector B. Understood? So when I know what is the area of a parallelogram, with that help I found what is the area of a triangle. So you can even find with only taking a triangle here. So what I do is, if this is a triangle, then again here I draw a perpendicular. This is triangle theta. This is a right angle triangle. We know that the area of a triangle is given by half base into height. So it is half base. We already know it is nothing but magnitude of A, vector A. Height, when I need to find the height, I again define sine theta for this right angle triangle. When I define sine theta for this right angle triangle, it will give us h divided by magnitude of b, the same as this one. So height, I definitely get it as magnitude of b into sine theta. So this can be written as magnitude of vector A into vector b. So area of a triangle is given by half of magnitude of vector A into vector B, and the area of the parallelogram, okay, area of parallelogram is equal to magnitude of vector A cross vector B. Next observation, as we have already discussed, vector product is not commutative. Vector product is not commutative. So A cross B will be equal to minus of vector B cross vector A. Remember this. Or vector A cross, or you can even write it as vector B cross A is equal to minus of vector A cross B. Okay, so remember this, very important. We're going to use this in problems. Next, vector product is distributive over addition. If you have three vectors, vector A, vector B and vector C, then vector A cross B plus vector C is equal to vector A cross vector B plus vector A cross vector C. Okay. Next, if A and B are any vectors and lambda is a scalar, then we have lambda times vector A cross B is equal to lambda times vector A cross vector B, or which can be even written as vector A cross lambda times vector B. Okay, this is about the observation. Next, now how to find the cross product between the two vectors when its component form is given. Let us see that. So if vector A and vector B is given in its component form, that is vector A is equal to A1i cap plus A2j cap plus A3k cap, and vector B is equal to B1i cap plus B2j cap plus B3k cap. Okay, then how to find the cross product between the two vectors? Vector A cross vector B will be equal to A1i cap plus A2j cap plus A3k cap cross B1i cap plus B2j cap plus B3k cap. So this is given by, okay, determinant of I, J, K, A1, A2, A3, B1, B2, B3. Okay, if you simplify this, how to simplify this? I should teach you. So if I simplify this, what we should do is the first column and the first row. First I am taking this element, the first row and the first column, you should neglect it. So you should neglect this and this one. So you get only the 4 numbers here. So here I cap, this I am considering, so I cap. So neglecting this and this one. So you should next cross multiply this. So I cap into A2 B3, then you should write minus, next B2 into A3. Okay, this is for first. Here, what I am doing is we are expanding along the first row. When you come to the determinant, you will understand how to do it with how to expand along all the rows or all the columns. Now, for the vectors, you shall just learn how to expand along the first row. So first element is over. So when you are writing the second element, it should be always minus in the middle. So next, so this is over now. Next I am considering J. So when I consider J, so now you should leave this row, sorry, this column and this row here. So when you leave this corresponding row and the column, so j cap into, now what you should do, remember that this is not there. So a1 into b3, a1 into b3 minus, next what do you have, b1 into a3. Next it is b1 into a3 plus, okay, k cap into. So next I am considering k cap here. So if we consider this, the corresponding row and the column should be neglected. So this column and this, that is the first row and the third column is neglected. So you have this 4 elements. So this will be a1 into b2 minus, next, b1 into a2. Okay. So this is how we find the cross product between the two vectors. So without this, if you just find the cross product between all the elements of each vector, again you will end up getting the same answer. Instead of doing that, it is very easy if we take the determinant and find the value. So these are the observations which is based on the vector product or the cross product of the two vectors. In the coming class, that is in our next class, let us solve the problems on these observation and also the definition.